October 15, 1941. Vologda Railway Junction, 450 kilometers northeast of Moscow. Steam rises from locomotives in the pre-dawn darkness, instantly crystallizing into ice particles that hang in air so cold it burns exposed skin. General der Infanterie Franz Halder, chief of the German General Staff, reviews intelligence reports in his heated office in East Prussia, studying photographs of Soviet rail lines stretching into the Siberian wilderness. He underlines a single sentence in red pencil: enemy rail capacity will collapse within 30 days of sustained winter operations. The assessment was unanimous among German logistics experts. The Soviet railway system, already primitive by Western standards, would simply cease to function when temperatures dropped below -20°C. Every calculation, every engineer, every historical precedent pointed to the same conclusion. What Halder couldn't know, what no German planner could imagine, was that 400 kilometers to his east, Soviet railway engineers were already moving 8,000 tons of military supplies per day through conditions that shouldn't allow any movement at all. The German certainty wasn't arrogance, it was mathematics. Soviet railways operated on a track gauge of 1,524 millimeters, compared to the standard European gauge of 1,435 millimeters. This 89-millimeter difference meant German rolling stock couldn't use Soviet tracks without modification. German logistics officers calculated that even if they captured Soviet locomotives intact, the primitive Soviet steam engines, many dating from the Tsarist era, would freeze solid when temperatures dropped to the levels typical of Russian winters. A Wehrmacht logistics report dated September 1941 stated with absolute confidence, Soviet rail capacity east of Smolensk will be reduced to 15% of peacetime levels by December 1. Complete collapse anticipated by January 15, 1942. The technical reasoning was sound. Water freezes at 0 degrees Celsius. Steam locomotive boilers contain thousands of liters of water. When a locomotive stops moving in extreme cold, that water freezes, expanding and cracking the boiler. A cracked boiler means a dead locomotive. A dead locomotive means no supplies. No supplies means no army. Colonel General Heinz Guderian, commander of Panzer Group II, wrote to his wife on October 20, 1941, "The railway situation gives me great confidence. The Russians cannot possibly maintain supply lines through what is coming. Winter will be our ally in strangling their logistics." German intelligence estimated the Soviet Union possessed approximately 28,000 operational locomotives in European Russia. Of these, perhaps 15,000 operated in regions that would experience winter temperatures below -20°C. German calculations showed that without heated locomotive depots, which the Soviets lacked in frontier areas, at least 60% of these engines would be immobilized by cold within the first month of winter. The mathematics seemed irrefutable. 15,000 locomotives times 60% failure rate equals 9,000 frozen, useless hulks of metal. The remaining 6,000 engines would have to supply the entire Red Army across a front stretching 2,900 kilometers from Leningrad to Rostov. It was impossible. The numbers said so. But there was something the German engineers didn't factor into their equations. Desperation multiplied by Russian engineering ingenuity equals outcomes that defy Western logic. At the Kirov Locomotive Works in Leningrad, a city already under siege, engineers worked under artillery bombardment to modify existing locomotive designs. At the Kolomna Locomotive Works, 115 kilometers southeast of Moscow, workers labored in 18-hour shifts to implement modifications that had never been tested beyond small-scale trials. The German assessment of Soviet locomotive quality wasn't entirely wrong. Many Soviet engines were indeed obsolete by Western standards. The Series O locomotive, the backbone of Soviet freight operations, was a design dating to 1890. The Series E, slightly more modern, dated to 1912. These were simple, robust machines built for a pre-industrial economy. What German analysts failed to understand was that obsolete and primitive are not the same as ineffective. The Series O locomotive, with its massive boiler and simple two-cylinder design, could be repaired by any blacksmith with basic tools. It didn't require precision German engineering or specialized parts. A village forge could manufacture replacement components. An intercepted Soviet railway document from November 1941, translated by German intelligence, produced confused laughter in Wehrmacht logistics offices. All locomotive crews are ordered to maintain continuous movement of engines. Complete stoppage forbidden except for loading/unloading operations not to exceed 45 minutes. Crews will sleep in shifts on moving locomotives. The Germans thought this was desperation, proof that Soviet logistics were already collapsing. They didn't understand it was the solution. The German logistics plan for Operation Barbarossa allocated 300,000 horses and 2,000 locomotives to supply the entire Eastern Front. This calculation assumed capture and conversion of Soviet rail stock, rapid advance to Moscow before winter, and collapse of Soviet resistance by October. By mid-October 1941, none of these assumptions remained valid. The Wehrmacht had advanced deep into Soviet territory, but Moscow hadn't fallen. Soviet forces hadn't collapsed. And winter was coming with a ferocity that would make the calculations in those confident German logistics reports look like the fantasies they were. On October 25, 1941, temperatures at the Vologda rail junction dropped to -15°C. German intelligence officers monitoring Soviet rail traffic noted with satisfaction that train movements appeared to be decreasing. Their instruments detected fewer locomotive signatures, less activity at switching yards. They interpreted this as the beginning of the collapse they had predicted. They were measuring the wrong thing. What was actually happening? Soviet railway engineers had consolidated traffic onto fewer, more efficient routes. Instead of running many trains at partial capacity, they were running fewer trains at absolute maximum capacity. Instead of stopping locomotives for maintenance, they were performing maintenance on moving trains. Instead of using heated depots that didn't exist, they were using continuous movement to prevent freezing. The Soviets were rewriting the rules of winter railway operations in real time, under combat conditions, while retreating under the weight of the largest invasion in human history. German confidence in Soviet logistical collapse wasn't just widespread, it was universal. From Hitler to the lowest supply officer, everyone agreed. The Russian railway system would freeze, the Red Army would starve, and German victory would follow as inevitably as winter followed autumn. In his diary entry for November 1, 1941, Halder wrote, "Enemy supply situation critical. Rail capacity reduced by estimated 70%. Complete collapse anticipated within 3 weeks. Final victory approaches." 3 weeks later, on November 22, 1941, temperatures dropped to -35°C across the entire Moscow front. Every piece of German equipment designed for European warfare began to fail. Tank engines wouldn't start. Artillery recoil mechanisms froze. Automatic weapons jammed. And in the frozen darkness, Soviet locomotives, primitive, obsolete, supposedly frozen solid, were moving 12,000 tons of supplies per day toward Moscow. The Germans would learn they had made a catastrophic miscalculation. But that lesson would come at a cost measured in divisions. January 15, 1942. Kirov Locomotive Works, Leningrad. Artillery shells impact 800 meters from the factory floor. The city has been under siege for 136 days. Civilians are dying of starvation at a rate of 4,000 per day. And in a factory hall lit by flickering electric lights running on generator power, engineers are building locomotives. Not repairing. Building. From raw materials, under bombardment, in a city supposedly cut off from the world. The first new locomotive rolled off the Kirov production line on January 18, 1942. It was crude, many components machined by hand, some parts salvaged from destroyed engines, the boiler made from steel plates never intended for locomotive construction. German intelligence, if they had known, would have classified it as non-operational. It pulled 52 freight cars loaded with 3,800 tons of ammunition from Vologda to the Moscow front. In -42 cold. Without stopping. The transformation was complete. The Soviet railway system hadn't just survived, it had evolved into something unprecedented in military history. By February 1942, the innovations developed under crisis conditions had become standardized procedures across the entire Soviet railway network. Order No. 312, issued by the People's Commissariat of Railways on February 5, 1942, codified the Continuous Movement Protocol. All freight locomotives assigned to military operations would maintain movement for minimum 20 days between major maintenance. Complete stoppage forbidden except for specified operations. Crews would operate in shifts, minimum 3 engineers per locomotive. Mobile repair trains would be positioned every 300 kilometers on major routes. The penalty provisions had been removed. They were no longer necessary. The system worked. And the numbers that German logistics officers couldn't believe, kept growing. In March 1942, the Vologda junction processed 31,200 tons per day. The Yaroslavl railway hub, considered by German intelligence to be functionally destroyed, was moving 42,000 tons per day. The entire Moscow railway network, which German calculations predicted would collapse to 15% capacity, was operating at 340% of its pre-war peacetime capacity. A German intelligence assessment dated March 20, 1942, stated with bureaucratic understatement, "Previous estimates of enemy railway capacity require comprehensive revision. Enemy logistics now represent primary strategic threat to Wehrmacht operations." But capacity was only part of the story. Speed was the other. Soviet railway troops had reduced average transit time for military supplies by 60% compared to 1941. A freight train traveling from the Urals to Moscow, 2,300 kilometers, now completed the journey in 4.5 days instead of 11. The secret: elimination of almost all stationary time. A typical journey now looked like this. Hour 0, train departs Sverdlovsk, 52 cars, 3,900 tons. Hour 8, hot coupling crew change at Perm, no stop, 12 minutes. Hour 19, mobile repair unit performs bearing inspection at Glazov, train slows to 8 km per hour for 25 minutes, never stops. Hour 31, second hot coupling crew change at Kazan. Hour 48, train arrives Moscow, begins unloading while moving through depot at 5 km per hour. Hour 51, unloading complete, same locomotive returns east. Total elapsed time: 51 hours for 2,300 kilometers, average speed 45 kilometers per hour. Compare this to German logistics on captured Soviet railways. Average transit time for the same route, 14 days. Average speed, 7 kilometers per hour. The efficiency gap wasn't just significant, it was existential. By April 1942, Soviet railways were moving 1.8 million tons of military supplies per month on the Moscow axis alone. This was more tonnage than the entire Wehrmacht supply allocation for Army Group Center, transported over longer distances, in worse conditions, using supposedly inferior technology. But the true demonstration of Soviet railway capacity came during the preparation for Operation Uranus, the counteroffensive at Stalingrad. Between August and November 1942, Soviet railways transported to the Stalingrad sector 111,000 tons of ammunition, 18,000 tons of fuel, 160,000 troops, 430 tanks, 600 aircraft, disassembled, and 14,000 vehicles. All of this moved through a railway network that was supposedly operating at 15% of peacetime capacity. All of this arrived on time, in the right quantities, to the right locations. On November 19, 1942, Soviet forces launched Operation Uranus with a 3.5 to 1 advantage in artillery ammunition over German forces. That advantage existed because Soviet locomotives had delivered 43,000 tons of artillery shells to forward positions in the preceding 30 days, in weather that regularly dropped below -25 Celsius. General der Panzertruppe Friedrich Paulus, commanding the German Sixth Army at Stalingrad, wrote in his diary on November 22, "Soviet artillery expenditure suggests supply capacity far exceeding our intelligence estimates. Cannot explain source of this material." The source was 1,200 Soviet locomotives, running 24 hours per day, through the coldest autumn in recorded history, delivering the avalanche of steel that would destroy the Sixth Army. Wehrmacht planners estimated that Soviet forces at Stalingrad could be supplied at a rate of approximately 800 tons per day. German planning for the encirclement assumed this supply rate would be insufficient to sustain major operations. Actual Soviet supply rate to Stalingrad sector in November 1942, 4,200 tons per day. The German estimate was off by a factor of 5. In preparation for Operation Bagration, the destruction of Army Group Center in June 1944, Soviet railways achieved capacity levels that redefined what was possible in military logistics. Between April and June 1944, Soviet railways moved to the Belarusian front. 2.8 million troops, 6,000 tanks, 36,000 artillery pieces, 5,200 aircraft, 300,000 tons of ammunition, and 50,000 tons of fuel. Total tonnage moved 2.4 million tons in 90 days. That's 26,600 tons per day, every day, for 3 months. Generaloberst Gotthard Heinrichsey, one of Germany's most capable defensive commanders, wrote after the war, "We could stop Soviet attacks. We could destroy Soviet tank formations. What we could not stop was the endless flow of supplies." Their railway system was the greatest weapon they possessed. By 1944, the Soviet railway network was operating at 520% of its 1940 peacetime capacity. The locomotives that were supposed to freeze solid had become the steel arteries of Soviet victory. The trains that were supposed to freeze kept running. And they delivered victory. June 1945. Railway Statistics Office, Moscow. Clerks compile the final operational report for the Soviet railway network during the Great Patriotic War. The numbers fill 847 pages. When the report reaches the desk of People's Commissar of Railways Ivan Kovalyov, he reads the summary page 3 times before signing it. Not because he doubts the figures, he knows they're accurate, but because he knows no one will believe them. Total tonnage moved by Soviet railways during the war, 444 million tons of military freight. To contextualize this number, if you loaded this tonnage onto modern 40-foot shipping containers and stacked them in a single line, they would circle the Earth's equator 2.3 times. The Wehrmacht moved approximately 180 million tons of military freight during the same period. The Soviet railway system moved 2.5 times more tonnage than the German system, despite being primitive, despite operating in conditions that should have caused complete collapse, despite losing 65,000 kilometers of track to German occupation. The locomotives that were supposed to freeze solid moved 19.8 billion ton-kilometers of military freight in temperatures that regularly dropped below -40°C. A ton-kilometer is 1 ton of freight moved 1 kilometer. To achieve 19.8 billion ton-kilometers, Soviet locomotives traveled a combined distance of 506 million kilometers while carrying freight. That's 3,380 round trips to the sun. In the cold. Without stopping. During the war, Soviet industry produced 833 new locomotives. This seems like a small number until you understand that each of these locomotives was in continuous operation within days of rolling off the production line, and each remained operational for an average of 2.7 years without major overhaul. Compare this to German locomotive production. 6,090 locomotives produced during the war, with an average operational lifespan of 1.1 years before requiring major overhaul. The Germans produced 7 times as many locomotives but achieved less than half the total freight capacity. Soviet inefficiency had become the most efficient railway system in the world under combat conditions. The cost was extraordinary. 4,057 Soviet locomotives were destroyed by enemy action during the war. 116,000 railway workers were killed. 310,000 were wounded. The casualty rate among Soviet railway troops was higher than among infantry units in some sectors, because locomotives couldn't take cover and repair crews worked under constant bombardment. But the system never stopped. On April 25, 1945, when Soviet and American forces met at the Elbe River, the locomotive that had pulled the Soviet supply train to the meeting point had been in continuous operation since January 12, 1945. It had traveled 8,300 kilometers in 103 days, through Poland and Germany, delivering supplies for the final offensive. It never stopped for more than 45 minutes at any point during that journey. The engineer who operated that locomotive, Senior Sergeant Viktor Kozlov, kept a personal log. His final entry, dated April 25, 1945, read, "Engine temperature normal. Boiler pressure normal. Coal supply sufficient. Water supply sufficient. Ready to continue east or west as ordered. 4 years of continuous movement. We did not freeze." After the war, captured German logistics officers were interrogated by Soviet investigators. The transcripts of these interrogations reveal something remarkable. Even after witnessing Soviet railway capacity for 4 years, even after losing the war partly because of that capacity, German officers still insisted the numbers were impossible. General Major Rudolf Toussaint, who had served as Wehrmacht transportation chief on the Eastern Front, stated in his interrogation on August 3, 1945, "The capacity figures you show me cannot be correct. The laws of thermodynamics do not permit locomotive operation in -40°C conditions without heated facilities. Your locomotives should have frozen. Your system should have collapsed. I cannot explain why it did not." The interrogator's response, recorded in the transcript, "Perhaps you should have asked us before the war how we intended to operate our railways. We would have told you, we will not stop moving." The lesson of the Soviet railway system wasn't about technology or engineering superiority. Soviet locomotives were genuinely obsolete by Western standards. Soviet infrastructure was genuinely primitive compared to German railways. Soviet maintenance facilities were genuinely inadequate by peacetime standards. But peacetime standards didn't matter. What mattered was adaptation, improvisation, and the willingness to rewrite every operational rule when survival demanded it. The Germans never learned this lesson. They kept trying to operate their railways according to the manual, kept waiting for conditions to improve before resuming operations, kept believing that proper engineering principles would eventually prevail. Meanwhile, Soviet locomotives, primitive, obsolete, supposedly frozen solid, kept moving. The final statistics tell the story of the greatest logistical achievement in military history. 444 million tons of freight moved over a combined distance that would reach to Alpha Centauri and back. Twice. In equipment that shouldn't have worked. Through conditions that should have caused complete system collapse. By workers who refused to accept that something was impossible simply because the calculations said so. On October 15, 1941, General Franz Halder wrote in his diary, "Enemy rail capacity will collapse within 30 days." On May 8, 1945, 1,331 days later, Soviet locomotives were moving supplies into Berlin. Halder's prediction was off by approximately 1,300 days and 442 million tons. The trains that were supposed to freeze solid delivered the victory. The system that was supposed to collapse became the iron foundation of Soviet military power. The locomotives that German engineers laughed at in 1941 were the locomotives that carried supplies to the Reichstag in 1945. In the end, the greatest miscalculation of World War II wasn't about tanks or aircraft or troops. It was about trains. Simple, obsolete, primitive trains that refused to freeze. And the railway workers who refused to stop moving them. The lesson remains: never confuse sophistication with effectiveness. Never confuse efficiency with capability. And never, ever underestimate what determined people can achieve with obsolete equipment when the alternative is defeat. The Soviet railway system didn't win the war. But without it, The war couldn't have been won. Every bullet fired, every tank deployed, every artillery barrage that shattered German positions, all of it arrived on trains that were supposed to be frozen solid. October 15, 1941. German generals predicted Soviet railway collapse. May 8, 1945. Soviet locomotives were still running. The prediction was wrong. The trains were right.